right, hello everyone, welcome back. In the last video we got our nodes revealing when we would click them. So now I want to create a function inside of the node class or a method that will allow me to count the adjacent nodes. So we will call this count adjacent bombs. And we're going to start off with a counter variable, like count equals 0. And there's not really a super clean way of doing this, so we're just going to kind of brute force it. And the way we're going to do that is whatever my current row and column is. So for example, if I'm here, then I need to check this. I need to check all 8 of these surrounding this one. So it doesn't really matter where we start, but we have to take some things into consideration. Like if we're along the side, then we don't want to check here because there's nothing there. If we're on this side, we don't want to check over here because there's nothing here. If we're up here, we don't want to check here. If we're in the corner, we don't want to check any of these 3 actually. So it's a little bit tricky, and we'll kind of try to figure this out. So the first thing I'm going to say is if col is greater than 0. Because if column is not greater than 0, then if we're just along here, then we're not going to check any of these 3. So if col is greater than 0, then we can check at least the one to the left. So we'll say if nodes col -1 row, or row col, oops, it's the other way around, row col -1, and we're not using Python, so we have to wrap this thing. There we go. If nodes row col -1, oh sorry, this dot col, this dot row, this dot col, there we go. Then we can count that one. Oh, sorry, dot has bomb. Then we say count plus plus. Oh, sorry, this is not a Boolean. This is sorry, not an, yeah, there we go. It's a Boolean value, so it's not a function. All right, so that will increase our count. Okay, so that's 1 done. Now we need to consider, yeah, let's continue this with the other 4, just the ones around. That'll take care of quite a bit. So we'll do this again. If this dot col is less than, and in this case it's going to be cols -1 because it's going to be 10 columns, and we want to reduce that to 9 to make sure we're not on the last one here, which is the 9th index. So this will prevent us from checking along the right side here. If, and then we do the same thing, nodes this dot row, this dot col +1 dot has bomb, count plus plus. Okay, do this again for the one above and the one below. So if this dot row is greater than 0, if nodes this dot row -1, this dot col dot has bomb, then we do count plus plus, and then if this dot row is less than rows -1, if nodes dot this dot row +1, this dot col dot has bomb, count plus plus. Okay, so we've taken care of 4 of them. Now we need to figure out the last 4. Well, it's kind of interesting because if we think about the upper left, we can check that either here or here, either of the 2. It doesn't matter. So I'm going to mark these just so I don't get lost and make sure that I have all of them. So left, this is the left node, right, this one's the one above, and this one's the one below. So let's make another one. We can just do it here, and we'll say if this dot row is greater than 0, then we can check if nodes this dot row minus 1 and this dot call minus 1 dot has bomb. So essentially we're also checking the row here, and then we can say count plus plus. Okay, we can do the other one here as well. We can also nest this all in here. So this one would be above left, left above. I don't really care as long as I know what that means. This dot row is less than rows minus 1. Then we'll say if nodes this dot row plus 1, this dot call minus 1 dot has bomb count plus plus. So this is the below left. Okay, now I can do the ones for the right here. So let's do the last two here. Now this one is going to be if, and actually it's the same exact logic here. So I'm going to copy this entire section out here. It's the same logic. We just had to make a couple little changes. Whoop, ooh, that's not good. Okay, make a couple little changes to it. A couple tiny changes here. So this is going to be the same thing here, but all we have to do is change these calls to +1, +1. And I believe that's it. And then we say above right, below right. And I think that's going to work. This one's going to be kind of hard to test until we get the bombs placed. So we're just going to trust that this works. But we need to call it here. Oh, this is, okay, so we actually need to set up an array of numbers, I guess. So we're going to have let number nodes equal this, and then inside of here it's going to be all of our image assets for each one. So we're going to have assets dot image, and then if it's 0, it's going to be unrevealed. Revealed. It's going to be the revealed one. And if it's 1, it's going to be 1, 2, 3, 4, so on. So 1, 2, 3, 4, 5, 6, 7, 8. So at least we'll have a kind of clean way of doing this. So now here, where we have our logic, instead of returning this, we're going to return number nodes of count adjacent bomb. So basically, if the bomb count, we have to return the count at the end, otherwise it's not going to work. So right here, after we get done with all this, return count. There we go. See, that's TypeScript helping us out. So this is going to, whatever the count is, if we count 4 bombs, it's going to return the number 4 here, which is going to give us the 4th index of this. So 0, 1, 2, 3, 4, and that's going to be the 4 image asset. So because we have the 0 here as well, that's going to actually kind of create a buffer where we don't have to change this at all, which is really nice. So it's going to be the 0th index is going to be this one. And that's a super clean way of doing it. We don't have to have logic for each of the 8 ones individually because we store it in a list and we get an index number. So this should work very well. We can't really test it, but hopefully it'll work once we get the bombs placed.